Hi everyone, today's Unit 5, Day 2, and we have one big idea today. We are going to solve exponential equations. Equations, of course, have an equals in them. Exponential mean there's an exponent in it somewhere. And there are two different kinds of situations that we're going to look at. The first one is if the variable, the x, is in the base. So if the variable is in the base, these are the steps. We're going to isolate the variable by itself. And then we're going to raise both sides of the equation to the reciprocal power to make that exponent drop away and to get the variable by itself. So step one is isolate the variable. Step two, raise both sides to the reciprocal power. And I'll show you several examples, and then we'll talk about what if the variable isn't in the base, what if instead the variable is up in the exponent. Those are the only two options. All right, our example one. I'll just scooch this up so if you're still writing there. Example 1 is x raised to the 3 over 2 power equals 125. We do have the variable isolated. It is all by itself. There's no extra stuff on the left side that needs to be moved over. So step 1 is done. Step 2, raise both sides to the reciprocal exponent. So I'm going to raise this side to the 2/3, the reciprocal of this. And if I do it to the left side of the equation, of course I have to do it to the right side as well. Now the reason that this works is, remember from day one, those double exponents, power raised to a power, the rule is to multiply here. So I end up with 3 times 2 and 2 times 3. Of course, 6 over 6 is the same as just 1. So by raising to the reciprocal, you get x all by itself. And on this side, I'm just going to need to either enter that into the calculator or go over on the side and do it longhand. 125 to the 2/3, just for practice. Remember that the bottom part is the root, so I'm going to take a cube root of 125, which is 5. I have to move that over a little bit. And then we're going to raise it up to the second power. The answer here is 25. So the bottom part root, top part exponent, but really at this point, if you're positive you know what these parts of each fraction does to this number, you can also just type this right into the calculator and get that. Okay, example 2. Example 2 is x raised to the 4/3 minus 1 equals 15. Oh, crud. Sorry, everyone. That should be a 15. My brain is already thinking ahead. Remember, the first thing is to isolate the x to get it by itself and move everything over. So I'm going to need to add 1 to both sides to make that drop out. I get x to the 4/3 equals 16. And now I need to raise it to the 3 over 4. And if I do that on this side, I've got to do it on this side. 4/3 and 3/4 makes 12 over 12, or 1. That just makes a plain old x. And on this side, you can type that, again, into the calculator, 16 carried up to the 3/4. Or you can do it in your head or over on the side. I'll take a 4th root of 16, which is 2, and then I'll raise it to the 3rd power. 2 to the 3rd is 8. My answer here is 8. At least one more for this, and then I'll show you the other type. Example 3, suppose I've got 2x to the negative 1/3 equals 6. Rule number 1, or step number 1 rather, is to isolate the x by itself. So this 2 would need to be moved over with division. So first thing you want to do is divide through by 2 to get this all by itself. And now I want to raise to the reciprocal. My question for you would be, am I raising to the 3 over 1 or the negative 3 over 1? We said raise to the reciprocal, but we never said anything about changing the sign. So whatever the sign is, when it was positive up here, we kept it positive. Now that this is negative, we'll keep it negative. There's no changing sign, it's just a reciprocal. So we're going to raise to the negative 3 over 1. Same thing on the other side. And remember what you're really doing, 1/3 times 3 makes 1. That's why this drops out. A negative times a negative makes a positive. So I do need the same signs just to get a plain old x. And then again, this can go calculator or brain. 3 to the negative 3rd is the same as 1 over 3 cubed. My answer here is 1 over 27. All right, type number 2 is, what if the x is not down here low in the base, but instead x is kind of up on the top of the exponent? So let me show you that. All right. Type number 2 is if the variable is in the exponent. If the variable is in the exponent, what we want to do is get like bases. Basically, get the bases to the same number. And then you can drop the bases and set the exponents equal to each other. Drop the bases, set the exponents equal to each other, and solve. All right, I'm going to start again with example 1 because it's kind of like a new little section. Example 1 for this is I've got 81 raised to the x equals 9 to the x plus 1. Now this might make sense to you and you might kind of feel like I already know what the x is just by looking at this, 9 and 81. But the idea here is that I'll show you this with kind of a simpler one, and then we can talk about what to do when they get more tricky. I want like bases. I can't randomly change this 9 and make it 81 because it's a 9, but I can rewrite 81 with a base of 9. 81 is the same, of course, as 9 squared. So all you're doing is replacing the 81 with something that equals 81, but now has that same base. This will always be the case that you'll come down to a smaller number, like, well, not always, but I'll say 99% of the time that you're coming to a lower number, you're not going to go up to a bigger number because this is a 9. I can't change 9, but I can change 81 and rewrite it. Now that I've got this double exponent, this is from day 1, a power raised to another power. The rule here is that you multiply. So I'll get 9 to the 2x equals 9 to the x plus 1. Well, the idea is if 9 to something equals 9 to something, and they're equal, those somethings have to be the same because the bases are now alike. So now you would just drop the 9s and set the tops equal. 2x equals x plus 1, and then solve it by moving that over. X equals 1. You don't have to do a check, but certainly I should have shown this on the first bunch too. If you want to check it, you can. 81 to the first power equals 9 to the 1 plus 1. Again, 81 to the first equals 9 squared. Yes, that is a good check, right? They're both 81. So these will always check. It's not required necessarily that you do a check, but you certainly could if you wanted to. Sometimes you had to change just one side. Sometimes you're going to have to change both of the sides. And again, you're bringing them down to a like base. Here's my example 2. Example 2 is 8 raised to the 2x equals 16. And it might feel like your base is 8. But remember, we need to make it 8 to a power. 8 to no exponent will get me to 16. So that's not going to work. And then you may say, well, 4. 4 goes into both of those. Well, I could replace 16 with 4 squared, but 4, again, to no exponent will get me to 8. It's always got to be raised to a power. So my common base here is actually going to be 2. Remember, 2 raised to the third power was 8, and 2 to the fourth power is the same as 16. Now you may or may not remember these perfect cubes and perfect fourths from Unit 2, I think it was, but as you work with these numbers more, you might have to just go to the calculator and try 2 to the third, 2 to the fourth, 2 to the fifth, until you kind of come up with something that equals 16 and equals 8. Here again, that double exponent, the rule is multiply, so I'll get 2 to the 6x equals 2 to the 4. And now the 2's just drop out and you set the tops equal to each other. and then solve for x. My answer here is 4, 6. I guess in a reduced version it would be 2 over 3. At least one more, maybe 2 more of this, and then we'll be finished. Okay, example 3. This one may be a little bit easier to see. Let's do 27 to the 6 minus x equals 9 to the x minus 1. When you're looking at 27 and 9, you want a common base. The common base being something raised to an exponent. My common base is going to be 3. Because 3 raised to the third is the same as 27, and 3 raised to the second power is the same as 9. So again, you're replacing that just with something that equals that. These are equal things. I'm just rewriting it. My double exponent here will distribute. So I'll get 3 raised to the 18 minus 3x equals 3 raised to the 2x minus 2. And now the 3's will drop out and you'll just set the tops equal and solve. I'm going to add the 3x over. I'm going to add the 2 over. X equals 4. I don't know if that's too quick on the solving, but hopefully that's okay. Just for the heck of it, let's throw one more under the camera and then I'll give you a few to try and we're finished. This is a nice example, but a little bit of an extension, probably something that we'll need to look at one more time when you come into class. But just for fun, let's try 1/2 raised to the x equals 8 to the 2 minus x. The common base here, it might be tempting to say the common base is 1/2, and I'm sure that there is a way to do it to the 1/2. This is already 1/2, so you'd have to think of 1/2 to what exponent would make 8. But a way that might be a little bit simpler is to make the common base this denominator. If my common base is 2, 2 to what exponent would have made it go down underneath and make it a fraction? 2 to the negative 1 is the same as 1/2. And over here I'll replace 8 with 2 to the third power. Here again these will distribute, so I'll get 2 to the negative x equals 2 to the 6 minus 3x. The 2's will cancel and I'll just set the tops equal. I'm going to add the 3x over this way. I get 2x equals 6, x equals 3. So just for the heck of it, I'm going to show you the check here because this is kind of a unique one. If we go back to the very original and I do 1/2 raised to the third power, and on this other side I do 8 to the 2 minus 3. So I'm putting the 3 in these two spots for the x and the x. This 1/2 times 1/2 times 1/2 is 1/8, or essentially remember from day one that both of these get raised to the third power. So 1 to the third is still 1, 2 to the third is 8. That makes 1/8. On this side I get 8 to the negative 1, which again is the same as 1/8. That is a good check. All right, so that's the idea of exponential equations, the two different ways that you can see them, with the x up high in the exponent or the x down low in the base. I'm going to give you a couple examples here for you to try on your own. So let's see what I have for you. Let's do just like one of each. And I'm going to go ahead and write them out, and then I'm going to work them out. So let me show you what I mean. I'll put this one as our first one. And then let's do this one as our second one. At this point, you would want to pause the video and try them on your own if you'd like to, okay? I would suggest doing that. I think it's a great idea. So I'll wait a minute for a quick pause, and then I'm just going to work them out. So if you actually want to keep working and just let it play, then you can look up at the end and see if our answers match. All right, how'd you do? I hope you did well. Whoops, it's off the page a little bit. Remember that tomorrow you do have a quiz on day 1, just the exponent rules. So you might want to look over those first 8 from video number 1. And hope you did well with this. Thanks so much, and we'll see you tomorrow. Have a great afternoon. Bye.